Hello, Kagglers. I'm just going to real quickly tweet that this is happening because I forgot to do it earlier. How's that? That sounds pretty good. Just check it in with the audio. Live coding kicking off now. Come hang out. Finally. All right. Hello. We are working on the same project we've been working on for a little bit. It has caught up with me. So that is the amount of, it's about 2 minutes of lag. So if I don't respond to something that you have said, it is not because I am not listening to you. It is because of the lag. Hello, Enrique, and hello, David. Welcome, welcome, welcome. All right, now that sounds good, I can get rid of that. So we are jumping back into this project that we've been working on a little bit, for a bit now, actually. And I was hoping to get some work done this week, but instead I got sick. So I didn't have the chance to work on it, but I did have the chance to think on it. So I was I'm going to apply some of the things that I was thinking about and see how they work. So just a little review, especially if you are joining for the first time in a bit. We are working on the Kaggle forum posts. So that includes not just in the discussion area, so all of these forum posts, but also comments that people make on different kernels, and also comments on different competitions. So you can look at a competition, you can see like the Severstall, Steel, Thingadoogle, there's a discussion in here, people are chit-chatting away, and I am trying to build an NLP pipeline. We'll take all of the things that people are talking about in Kaggle, cluster it together into a manageable number of clusters, and then have a summary or sort of quick way of understanding what's going on in those clusters. And we've come a really long way. So we actually already have gotten, let's go back, nope. There we go. So we actually have already done our clustering, and I'm fairly happy with it. I've done quite a bit of pre-processing of our forum posts, some of which is Kaggle specific. So for example, people are super polite on Kaggle, and there's a lot of posts that are like, hey, thanks, or nice job, or thanks for posting, or wow, this is a really good kernel, or stuff like that, which very happy to see. I would be upset if those types of posts went away, and I don't think they will. But as clusters, not super informative, right? I'm more interested in getting information on bugs that might be happening, on, I don't know, if there's a new model that people are talking about all of a sudden, I want a way to quickly, capture that information and communicate it out. So, a little sip of water. How can we do that? Blah, blah, blah. What was I talking about? I was talking about the pre-processing. So that was step one. We're also removing HTML tags. We haven't removed URLs, I don't believe. So URLs are still in there. And then we are not actually extracting any keywords. As I remember, this was broken in a way we couldn't figure out how to fix. So that's something we can check into later. Actually, while we're doing this, I'm going to... I don't want to copy and edit. I want to edit this version. There we go. So while we're going through this, I'm going to kick off and run everything. And it'll take a little bit to prepare the kernel because I'm attaching all of the Kaggle forum posts. So we have under workspace. No, it's just going to load for a bit. So we have all of the data from Kaggle that's publicly available as a data set called MetaKaggle, and I'm attaching that. So every time I launch a kernel, it needs to reattach and run. There's like a white spot behind me? What's that? What's the white spot behind me? Oh, one sec. I think I can fix that right away. Nope, not that direction. Much better. Chroma keying is extremely light sensitive, and the sun came out in Seattle, and I had a sunbeam on my green screen. So, fixed. Excellent. Z says, I love how she looks like a proper programmer girl. Thanks. It's my job. Okay, so we've run all of this. We do our, we also, this isn't shown in the kernel, but we did a bunch of custom functions. We did our custom preprocessing. We are using word-to-vec vectors that we have fine-tuned using the Kaggle data, so it includes Kaggle-specific terms like kernels or shakeup or leaderboard or stuff like that. Deepak says, hello Rachel, I love all your live coding sessions. Wave says, hi Dr. Rachel. Hello, thank you. Yep. Oh no, I've closed the chat. One sec, let me get that back. Sorry, I was really sick yesterday, so I'm still getting back into the swing of things. Custom embeddings. Then we're using spectral clustering. So spectral clustering is a clustering technique that is graph-based. So if you can imagine all of the, in some multi-dimensional space, you have each of your text posts. In this case, it's a, oh, that's right. I forgot how we did post embedding. So the way that we did embedding over the post is we took the average of the, so we took the word embeddings for all the words and we just averaged over them. So we sort of squanched them down. So that's the multi-dimensional space that we're clustering in. And then spectral clustering, I forget, we went through the math a while ago, but basically it draws edges and connects things to the graph based on information gain? It may not be information gain. Anyway, as a type of clustering, we got some clusters out. And you can see that we do tend to have, and we've run this now several times because it's just looking at the last day, I believe, or maybe the last week. So you'll see that we have our normal pattern that we see, which is that we have one very big cluster that's sort of like the miscellaneous cluster that has most of the things in it. And then we have lots of smaller clusters, and we sort of have like almost like an exponential decay. So some clusters, we have like one or two medium-sized clusters and then many smaller clusters. And if we take a look at them, you can see, so it looks like this cluster is a cluster of people sharing links, potentially specifically on competition kernels, it looks like. And this cluster looks like it's a half sort of a polite cluster. These are all on kernels, and then half sort of like specific questions about the code. So here one person is asking, where's your document term matrix from? Somebody else is asking, have you tried k-fold cross-validation? So that's a cluster. And then this one is people who are talking about potential issues, and it looks like they're getting help with their issues, and that's been clustered together as well. So Jake says nodes cluster over cluster. Oh, that's about the spectral clustering. Thank you. Haimanasu says, did you try to use the Spacey framework for natural language processing? I have used Spacey quite a bit. Spacey is extremely user-friendly. They have a fairly small library of methods implemented in the library, and they aren't... No, we didn't use Spacey for this. I don't want to get too far down that track, but no, I'm a huge fan of Spacey. I think it's a great framework, but for this we're using a collection of different libraries. Did I fine-tune the word-to-vec embeddings? I did, and we fine-tuned them on all of the Kaggle forum posts before like a month ago. Jake says, what's the purpose of a spectral cluster? So a spectral cluster is just a cluster in some multidimensional space, where the multidimensional space here is sentence embeddings, document embeddings, done in kind of a simplistic way. So that's something where we could explore other approaches in the future as well. And Hegdashin says, it's my first live session. It's pretty awesome. Thank you. And Jake says, are you talking about index clusters? I'm not familiar with index clusters. So that's what we've gotten so far. We've gotten to the point where we have clusters, and we've done a little bit of hierarchical clustering as well. So taking clusters that are bigger than we expect them to be. So I set the expected cluster size as the square root of the number of posts, and also the starting number of clusters as the square root of the number of posts. Right, so if we had 4 posts, I'd expect 2 clusters of 2. If we had 9 posts, I'd expect 3 clusters of 3. If we had 16 posts, I'd expect 4 clusters of 4. That sort of thing. And that's just an assumption that I'm making that because Kaggle conversations tend to be back and forth, as the number of total posts increase, they will be on. The number of topics won't increase linearly, right? Which may or may not be a good assumption, but it's one that I've made. And then we did a little bit of multi-level clustering. So we took the biggest cluster and then we clustered it, and you can see that gets us a slightly more even distribution of posts per cluster. And then we've done a tiny bit of visualization. So we tried a word cloud. I don't know what this NI and TS is from. We do tend to see TS quite a bit. It could be from a specific competition, maybe. Hi, Citrone. Taha says, searched, what is Kaggle? And your live video came up. I guess I'm learning clusters now. Welcome. Kaggle is, one of the things you can do on Kaggle is write and run code. So that's what we're doing on data that happens to be about Kaggle as well. Albert says, interested in the Spacey statement. Can you share the opinion? Spacey is like I use Spacey and I use NLTK quite a bit. I use both of them. And I like to say that NLTK is more like a standard transmission. So one where you have to shift it yourself. There's a lot more options. And if you know what you want and you need a lot of fine-grained control, it can be very helpful. If you don't know what you're doing, you can get yourself into trouble fairly easily. Whereas Spacey is more like an automatic transition. A lot of the work is sort of done like mysteriously under the hood for you, which is really nice if you don't have like a deep background in natural language processing. You're playing around with things and you don't need to adjust a lot of knobs. But for this, I am not using Spacey. I don't even think that Spacey does unsupervised clustering. Anyway. Okay. So, what we did last week? Was it last week? It seems so long ago. Yeah, I think it was last week. Is that we worked on implementing a measure first proposed by somebody in these course slides of term saliency. So basically, it's a normalized measure of frequency. I'm trying to click on the courses. There we go. Render the markdown, and then I shall click. So we looked through and talked about these slides quite a bit 2 weeks ago, perhaps. And it's just slides from a lecture on text visualization from a graduate level computer science course at the University of Washington, which is actually where I did my PhD. Not in computer science, but the measure that we were talking about was called saliency, and it was it not called saliency? Have I just been calling it saliency? Term document term matrix. Well, maybe I am making up that it is actually called saliency. So here's scatter text, which we don't have a binary distinction, so scatter text doesn't make a lot of sense as a visualization for us. And I think it also has a Java dependency or a JavaScript dependency. I don't know. I've tried to get it working in kernels before and was frustrated. All right. So what we did last week, and do I not have data output? Oh no, it ran with an error. All right. So problems have occurred. All right, let's pop this open. So basically what we're doing is we're taking the frequency of every term in our corpus, in this case our corpus being all of the forum posts on Kaggle, and we are, it's green, you can see through it except for the shadow is that the color is off enough for chroma keying. Anyway, I keep forgetting about green things. So what we're doing is we're taking the frequency of terms across our corpus. So we're tokenizing. We're looking at each word individually. So we're looking at all instances of the, all instances of Kaggle, all instances of model, all instances of competition or whatever. And then we're counting how often they occur. And then we're normalizing. I should actually start this going because this is going to take a bit to run. And then we're normalizing based on how often they're used, right? So we normalize them by taking the log of the frequency. Let's see, it's in here somewhere. So we take the log frequency, and then we divide it by the log frequency of the most common term, which is the, because it's an English language, mostly an English language corpus. We have some other languages as well. Jake says Scatterplot, scatter text is the specific library that I was talking about. Scatter text. This one. Is the spectral clustering based on a Scatterplot table? Kind of. So, it's, so our, we're working in an embedding space, right? So in this case, our embeddings they're 300 digits long. They're arrays of length 300. And you can use your 300 values, which you have for every word and also every post, because we've taken all the words from a post and then averaged them down to a single 300 length vector or array. And you can use that as a 300-dimensional space, right? Which, I mean, you can't conceptualize because that's how humans work. And in that space, some things are closer to each other than others, and we're drawing lines between them. So it's kind of like a scatter plot, yes, in 300 dimensions. So kind of. And that's super common with embedding-based stuff in general. Let's actually make that a little bit bigger, make this a little bit bigger so you guys can actually read it. So what we're doing here is we're taking all of the forum posts, removing HTML tags, because I don't care about those. We are tokenizing, so that's what the little text bit is there. Sorry, no, we're tokenizing here using NLTK, which I mentioned is sort of the manual version of NLP libraries. And then we are removing single character tokens. So we are removing tokens like A, like the word A or the word I. We're removing numbers, if people are reporting numbers. And then we're removing non-breaking space, which we were seeing quite a bit in HTML stuff. So just getting rid of that specific character. And then we're making everything lowercase. So the with a capital T and the with a lowercase T are considered the same word. And then we're taking the frequency distribution. And my hope is that we only need to do this once. So we didn't really optimize this step. This is what's taking so long is the frequency distribution, I'm pretty sure. So it's going through and it's counting all the words. I don't know if you can tell, but the little CPU meter here is in the red. It's using a lot of CPU. It's pretty much taking all of its compute to do this, and the RAM and the hard disk are both in the green. This is relatively new, I think. This little guy. And then once we get that, we're going to print out the topmost 50 words, their raw frequency, their log frequency, and then their normalized frequency. So the log frequency of the word divided by the log frequency of the most common word. And the normalization means that we can compare frequencies across corpora, because we're going to always have them in a range between 0 and 1, if that makes sense. Yeah. Jake says 300 dimensions sounds mind-boggling. It is fairly little for word embeddings. Actually, I think 500K aren't on 500K. I think 5K word embeddings. I think Stanford has some. Let's see if I can find them really. We're doing word to vec, but I think Glove goes up to what's the size? So these are 300. Maybe Gloves are 300 by default. Anyway. And it's still thinking. And then anyway, once we've done all that, we should be able to write this to file and then save out our nice CSV file with all of our frequency information. And I thought that I had run this and not run into any problems, but as it turns out, I think I actually did run into some problems. So I'm going to take a look at the errors and see if I can get more information. Oh, I can never remember how to get the error log. ViewForks versions. Is it here, maybe? Okay. Delete kernel, copy and edit, access, none of that. And I didn't get any output down here. Ryan says, any plans to periodically retrain your embeddings? No, not right now. Maybe. Zitron says 600 for Glove, and then, no, I think I was wrong. 300 is the standard. I've definitely seen bigger ones, especially, I think in the ACL circuit, like 3 or 4 years ago, people were doing things bigger than 300 pretty routinely. But I mean, that's research stuff. Ooh, sorry. So very possibly no one was actually using those. People were just creating them for fun. Deepak says, is it correct that we don't use NLTK for production? Is it only used for research or education purposes? I mean, you can use it for production. It has a license that allows that. Yeah, you definitely can. Spacey is a little better optimized for quickness, but if it's something you're only running once or twice, it doesn't matter that much. Zitron says in the Word2Vec paper they use 1,000. Yeah, I knew I was remembering something slightly bigger. So, I mean, the libraries, to reply to Deepak's question, the libraries that you use are going to depend on your specific use case. Oh, it's still going, huh? Oh, I don't need to do that twice. Why am I doing that twice? Interesting. Okay, so if we look through at the most common words, we can see that the most common word is the, raw frequency of like 1 million, log frequency of 13, and then normalized frequency of 1. So remember that we are normalizing based on the most common word, which in this case is the, so dividing it by itself gives us 1. And then as we go down, we get words that are less and less and less frequent. And I think actually it might be this part that was taking so long. Because I think I said first 50 here, and I definitely am actually just printing out all of them, so that one's on me. Let me update my comment. Okay, and this is literally the same thing twice, so we can get rid of that. Doop. And then here we should be able to write to file. Let's see. It might take a bit, and I don't know where the error would have come in either, because when I ran it, you can see if we look at the versions here, version 1 has an error, and I don't know what the error is. So let's try and run that and see if that writes to file. All right. Ryan says, in some of the original word embedding papers, they did ablation studies and found there is clearly diminishing returns beyond 300. Ablation, so more than 300 rather than less than 300? I will also say that just because there are clearly diminishing returns does not mean that NLP researchers are not going to do it if it gets them, you know, that last 0.1% to get to the top of the state of the art on a specific task. Much like on Kaggle. But noted. Enrique says, would GPU improve performance? Probably not, because we're just writing to file right now. And it would be, I don't think you can parallelize writing to disk if you're writing to a single disk. And yes, it is Python. All right, so we should be writing to file. Maybe the errors that I was getting, let's actually comment out this line and then try to run it again and see if that works. I know there's a Jupyter shortcut for commenting out a chunk of text, but I can never remember what it is. So, right lines. 1, 2, 3, 4. So I'm just quickly checking out. Here we're opening a file. I'm writing a single line that has the headers in it. So the word, the raw frequency, the log frequency, and then the saliency measure. And then for word and frequency in this most common, I'm writing them out. And actually, I wonder if I want to do, I wonder if I want to do only the, sorry, I undid and then redid some things. I wonder if I want to do only like the most common 1,000 or 10,000. So my thinks is, we have this normalized measure of frequency, right? Based on the full Kaggle forums. I want a way of figuring out which words are most distinctive for a specific cluster. So my plan, and I was hoping that I would just have my like frequency table written to a CSV and I could import it and everything would be great, but that doesn't always happen. And my plan was, let's actually stop this and just do the most common 10 and make sure that our code is working correctly. And then we should be able to do bang, ls, and then we should be able to do bang cat Kaggle. Okay, yeah, girl, you are going to have to write a new line. Nope, it's the other way. Okay, so it might be that I was getting that. There we go. And then new line after the header. That should look much better. And now I should have a valid CSV out. Excellent. Fixed the problem. So it might have been that my error was that I was getting out a... Oh, okay, that is that. I thought that this word was the again, and I was like, that shouldn't be happening. It didn't happen. That should be happening. The should not be happening. All right, let's get rid of this cell, and then run this from the top. And that's going to take a little bit because I need to rerun all of my code top to bottom. Okay, so while that's running, so my thinking was that since we have our normalized measure of saliency just means like importance, or noticeability actually. My thinking was that for each cluster, we could do the same process where we get the frequency distribution and then we normalize by the most common word in the cluster. And then we find the words that have moved the farthest from the from their expected distribution given the corpus as a whole to their new distribution in the specific cluster. Some problems there. A, out of vocabulary words. How are we going to deal with out of vocabulary words? Let me write these down. Go. to do. So we want to, for each cluster, find the normalized saliency measure, and then rank words based on difference from based on difference in normalized saliency in whole corpus. So what this should do is this should get us the words that occur much more often than they should if we were just randomly sampling from the whole corpus, which, I mean, you never randomly sample in actual language use, so it's a little bit weird. Edge cases, add vocabulary words, add smoothing or set corpus frequency to 0. So words that we haven't seen before, of course the normalized frequency is going to not exist in our database that we have created. So this dude over here, which you can see is still committing. So we could either add a small amount to all of them or just set them to 0 and be like, we never saw it. Which might make sense because we have a range here of 1 to 0 anyway. So that could be a good choice there. Make sure to match pre-processing. I really want to make sure that we remember to make things lowercase so that we aren't comparing uppercase words to lowercase words because that'll split the groups. Where's my T? Okay. So add vocabulary words are one thing. The other thing is I don't necessarily know that the words that have the biggest shift are going to be the most important. Okay, let's think this through. So we have a log distribution, right? So it decays pretty quickly. So moving from sort of the middle of the distribution to the top of the distribution is going to be a big shift. Moving from the end of the distribution to the middle of the distribution is going to be a little shift, right? Because even though you're moving an equal distance along this axis, you're not moving an equal distance along this axis because you have to climb this like weird mountainy hill thing. So I don't think we actually want to look at, So do we want to look at the, Okay, sorry, so what I'm thinking, things I'm thinking through here. So one thing is that by committing to a log normalization, we are prioritizing movements towards the top of the frequency, which I feel like is correct. And even pretty big shifts across the tail aren't necessarily going to be that important. Out of vocabulary words will always move up quite a bit because they started at 0, and if they're showing up in a relatively small text sample, they're going to have a much higher log frequency than we would expect given 0. So using the log protects us from words that were out of vocabulary suddenly having a large change on the x-axis but not the y-axis, or the other way. Zitron says, why not try fast text and see if it handles out of vocabulary better? I'm not worried about things like the embeddings. I'm worried about specifically the frequency ranking, which fast text won't have. Yeah. Ryan says, not sure if you're on a GPU kernel, but you're right at the upper bound of GPU kernel time, so you might have run out of time if you are. I'm not. I'm in a CPU kernel. Control / Hamanasu says to comment multiple lines. Dback says, yes, I do live coding. This is not for interview questions. Although I think it might make a pretty good interview question. This is how I talk through my process when I am doing tech interviews. Sounds like she's trying to plot the data on a graph. Not really. I'm just using, I tend to think about distributions and things a little bit easier if they are visual. So I'm thinking about how a change in our measure is going to change the output. Yeah. So basically my question that I'm trying to figure out for myself is, do I care more about the log saliency, this measure that we're using to normalize, so we can compare directly across corpora, or do I care about the rank? Because another thing that we could do is we could take the rank of the terms, right, from most common to least common. We could have the expected rank given our whole corpus, right? So in the whole corpus, we have all of the words that people have used on Kaggle, but maybe in our little sub-corpus, people are talking about, have like Kaggle is the best. And so we have the expected rank of all of those words given their placement, given their frequency in the large corpus, like we would expect the to be the top. So the rank difference is another way that we could try to normalize for the difference in vocabulary size, and also text size. But the problem with relying on rank differences and shifts in rank is, especially if we're starting out of vocabulary stuff at rank, end or whatever that is, then they will always shift up. So out of vocabulary words are always going to have a higher rank shift than they would if we're sort of moving along a log scale and then using the y-axis to determine the rank, basically. Yeah, I'm happy with this. I think that it solves a lot of problems that we might have otherwise. Also, very infrequent words, right? If something is very infrequent, whether or not you see it in a large sample is just basically going to be down to chance. So even if we see something very, let me back up. So you are almost always going to see something very infrequent in a small sample out of a large sample, right? If it has that sort of Zipf-ian distribution. So if I have, 5,000 words and 2,500 of them I've only seen once, and then I have a smaller text sample out of the larger text sample that I got that frequency distribution out of, I'm almost certainly going to see one of those 2,500 words that I only saw once. Do we think that those words are necessarily more important to understanding the content of the cluster? I don't think we do. But if we saw one of those words that's very infrequent becoming the most frequent word in the cluster, or like the third most frequent in the cluster, and then the normalized frequency measurement that we're using is much higher than it would be otherwise, then I think that that is a good outcome. Also thinking about, it's up here in my notes, also thinking about the... in the slides that we looked through, there was a bit of a work on human text summarization, and they found that humans tended to use not the most frequent nor the least frequent terms, but they tended to use the ones somewhere in the middle. And because even with a small sample out of a large sample, if you have something that's very frequent, you're almost certain to see it. I think that this will, which means that there's not going to be a large change, right? So if that's the most frequent word in a big corpus, it's also probably going to be the most frequent word in a small corpus. And if you subtract, one from one, you get 0 if they're always the most frequent word. So that change is not going to be very big. Similarly, if you have a very rare word and you happen to see it, once, because it's on a log scale, that change is also not going to be very big. So that'll be sort of near the end. And then things in that sweet spot, that sort of elbow motion, will be, you don't have to move very far in the sweet spot to really change your value. So yes, I think that using the log distribution will also capture that, that way of working on, that way of looking at not super frequent words and not super infrequent words. So yeah. All right. You still committing? Yep, they're still committing. So we might as well start working on doing the same thing that we did here for the clusters. So get rid of that. All right. Let's take a look at one of the clusters. Sorry, so that was a lot of me thinking aloud, and these are some things that I thought about, but certainly not I hadn't gone through that whole thought process before. But yeah, I mean, one of probably the central challenge in NLP is how do you turn a word into a number, and how does the way that you turn the word into a number affect the way that your measurements and your methods work. And that was it. That was the hard part of NLP. Now we actually get to do the coding. All right, so what we need to do is create a corpus from a cluster. Preprocessing, and then we need to get frequency distribution, and then we need to get saliency measures. Okay. And this one, this guy here that we're running that is taking quite a bit, I am okay with this taking quite a bit to run because we only need to do it once. And hopefully this time I won't get an error. And I do see the little sunspot behind me, and I don't know how to avoid it. See? Pull it. It goes away if I cover it with my hand. Oh, I guess that's always true, huh? All right, so here's our little pre-processing step that we were doing that I'm just going to copy and paste word for word. Do we have NLTK in our imports? No, we do not. I'm not going to rerun this whole cell, though, because it'll reload in our data, and that takes a bit. So I'll just... all the way down here to the bottom. Have we really not imported NLTK anywhere? We really haven't. All right. I thought we used it for some tokenization earlier, but I guess we didn't. So this is the sort of thing that Joel Gruss hates. If you didn't see the interview where he talks about how much he doesn't like notebooks, you can check that out on the channel. All right, so this is the pre-processing. We need to get the specific text that we want and call it text. And I want to make sure that I do the same pre-processing here that I did when I created the data set that I'm going to compare it against, because otherwise we're not going to be able to do like string-wise comparison. You still running? Still running. It's a long one. To be fair, it does take a while. It's quite a big corpus. I don't think the frequency distribution method is super duper well optimized, and also I'm running it over all of the text at once instead of sort of like looping through and doing it for multiple parts at the same time. So that might be part of the problem. I don't care enough to optimize it well. Ravi says, I thought you were sick. I was sick yesterday. I was not in a good place. It was not a fun time for me, but I'm much better today, which is fantastic. I don't know if you can tell my throat's still a little bit raspy, and it's not because I was coughing. It wasn't fun. I think there's something going around tech circles in Seattle, because at least one of my friends was tweeting about how they also had similar symptoms. Not gonna go into detail. Anyway. Okay, so we need to do this, and then we need to get the frequency distribution. And I'm actually not interested in all of these pieces of information that I'm getting for my other... I'm not interested in all of the pieces of information that I'm getting for my other words, my corpus-wide measurements, because I only care about this one. And I could, I suppose... Let's copy and paste that. I suppose I could calculate all of them. The reason that I'm doing them in my big file that I'm only doing once is because I only want to do it once. what was it? Was it control slash? Shift control slash? Shift slash. Control slash? Control alt slash? I swear I'm doing it. Is it not selected? Control slash. Try it again. Control slash. Yeah! Thank you! Harmonasu. I feel like distribution is misspelled. Are you done yet? Nope, still running. That's okay. So for word frequency in fdist.mostcommon, we are only interested in, actually no, I think we actually need the word as well. So we're interested in getting the word, which we are getting from this, this iterator, and then we are interested in this measure of saliency because that's what we're going to be comparing. And the reason that we want to do that rather than the frequency or the log frequency is because this is normalized for corpus length, and the log frequency and frequency measures are not. Your frequency numbers will always go up if your corpus is bigger because there's more words, so you can count them more times. I should probably put this in a dictionary because we're going to be doing a lot of comparisons, and dictionaries have constant lookup time. Yeah, constant or linear. Very good. Much better than the comparisons in a DataFrame. So, Rosalgul says, great talk by Joel Gruss, must watch, the dude's hilarious. Yes, and he has many opinions, some of which I agree with. We did an interview here on the Kaggle channel. Also, fun fact about Joel is he worked on the Elmo paper, which is one of the first papers, or was the first paper to have a Sesame Street name as the model name. Okay. I just need to look up how to do a dictionary, y'all. I always forget the syntax for dictionaries. You know what my least favorite thing about Python dictionaries is? I don't know that I've mentioned this on the channel before. Frequency values, saliency. I don't like that they're not sorted by default. I know that sorted dictionaries are a new thing in Python 3.6 maybe, but when you say the word dictionary to me, as a person who speaks English, I assume it's going to be sorted alphabetically, and it's not, and it drives me nuts. And I'm sure that it is some sort of legacy naming thing, but I think it's a bad name, and it upsets me. And it made it really hard for me to understand dictionaries when I was first learning about dictionaries. All right, if we try to assign something to an empty dictionary, will we have a problem? Probably, right? And I think it's looking for a string, but it'll treat this as a string. Let's call this cluster dict. Oh, wait, nope, we've gone with, what's this one? Snake case? What is it with underscores? The underscore case, so we should probably stick with that, huh? And then we want to create an empty dictionary. That's the one. How do we do that? I always forget. Dict. All right. Cluster dict equals dict. And we don't need to pre-allocate memory for it because it's not an array. So we should be fine for looping through a dictionary and adding things. Especially because, so one problem would be if we were trying to assign multiple things to the same key, but because this is a data structure where each word will only occur a maximum of 1 times, we don't have to worry about overwriting keys. So we don't need to deal with any of that nonsense. Yeah. Jake said, if you have time, could you go over again how you're going to tackle this task? Like the... Better spell that the same both places, huh? Are you done? Still no. Okay. If you have time, could you go over again how you're going to tackle this task? I will go over it by tackling it. And Nishant says, declare an empty dictionary above. Yeah, I got up to it. I think there's about a 2-minute delay between me and you, so I'm not ignoring you. I just didn't see it in time. All right, so we are getting the saliency measures. We are putting them in a dictionary. For faster lookup time, and then, yeah, and I think you don't want to loop through dictionaries for mysterious reasons that I'm sure have something to do with the data structure that I just don't have a good mental model of. But because we're other data set we're going to be running, okay, so what I'm thinking is the other data set we're reading in as a data frame, and oh hey, we don't have to loop through that, right? Except that the words in our cluster are almost certainly going to be a subset of the words in our bigger set, so we do have to loop through it to find out, No, we don't, because we have we've tokenized it, right? So here we have all the words that have been tokenized. So that should help us because we can loop through the tokenized list instead and then look up in the dictionary, look up in the data frame, get all the info we need. Okay, excellent. That makes sense. So let's create a corpus from one of our clusters just to make my life easier. And excellent. And I think I can do this. Okay, so I believe what my output from get post info by cluster is it's all of the information about the post, including the date it was made and also the form it was made in. Let's create a new cell to do this in, so we don't have to run all of this. So let's get the post info by cluster 1, where we're doing the subcluster. So this isn't going to be the one that has like 100 posts in it. It's going to be a little bit of a smaller one. We don't need those outer parentheses, so let's get rid of those. So, okay, yeah. This is a data frame. Actually, let's not get 1. Let's get 2, which would be a little bit smaller. Yeah, okay. So 2 is a little bit smaller. And... let's just get the, can I ask for just the message here? Will that work? Yeah, excellent. Okay, and then I need to convert this to just a string, which we did in here, so I can look that up. And again, we're doing that thing where we're running something over a really big string, but this string is not as big, so I'm not as worried. There we go. Excellent. As type string, blah, 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 blah. All of this stuff. So we're casting the whole thing as a string, and then we are concatenating it with spaces between it so we don't end up with copy. So we don't end up with words smooshed together. All right, here we go. One big old stringaroony. Oh, okay. I was like, it looks like we haven't removed all the HTML. I think we have removed all the HTML, and this bit here is just a code snippet that somebody has. So we probably want to keep that. Okay, and then let's call this text. And if I remember correctly, we can break it across multiple lines like so. Yeah? Yeah. Excellent. And now we should be able to... Yeah. Oh no. Mistake. I need to import math. That's right. You can't just take a log in Python. You need to import a module to do it, which I realize is not that unreasonable, but I'm used to, or much of my grad work was in R, which is a statistical programming language, and everything's just like built in. Like, of course the log is built in. Of course you don't have to import something to get the log. You need to get the log all the time. Why would we make you import something? But Python is not a statistical programming language primarily, so it makes sense. Nishant says, to get a list of keys, use mydict.keys and use it to iterate over the dictionary and access values as mydict key. Helpful. Zitrone says, instead of casting a string as string, you can add d-type string when reading the file with pandas. I think there was a problem when we tried to do that earlier, and I don't remember what it was. I think we ran into that problem before with the Kaggle dataset specifically. And Hierarchical says, just tuned in, what's the problem statement? Right now, we are still waiting for this to run. Right now, we are working on getting a measure of saliency for words in a cluster that we have made. So basically, we want a way to quickly say what the most important words are in a cluster. All right. So if I do this, it's just going to be like, it's a dictionary. Oh, no, it will print it out. Okay, excellent. So we can see that the most common word is the, and then to, and then quotes, and then and in it for of ... gt 2 backticks, which I believe is what you use for code samples. My this amp. Maybe we didn't remove all of the HTML stuff super well. Memory racers apostrophe L. Competition, machine, want, not, prediction, share, everything, suggestions, training command, 4 out of 1,000, which apparently is, okay, so this looks like the part of the distribution where things are shown once. Or twice? Interesting, so we have a lot of things that are only shown once that have a measure of 0? Does that make sense? That something would have a measure of 0? Yes, if the log frequency is very small, I think it'll be like a float problem. Ugh, spam. Okay, so I think it does make sense that we can have things with a measure of 0. So if one of these things with a measure of 0 moves up to have a measure of like 0.18 or 0.37, that's pretty important. If something moves up from like 0.97 to 0.1, that's less important, right? So that's what I was talking about with like a movement bigger movements up the rank should create a higher value and make it easier for us to tell which is the most important word, hopefully. Okay. Zitron says, instead of casting a string, why not remove URLs? I don't want to remove URLs because URLs could be topics on Kaggle. So if someone is sending a link to a specific competition or a specific kernel, and a lot of people are linking to a specific topic or competition or kernel, I want to know about it. So I'm considering them tokens for the purposes of this particular project. But I mean, you could choose to remove them in another case. All right. And it is 10, and this one is still not running. Okay, but I think we're pretty much set up for what we need to do next, which is to loop through all of these words, which, as Nishant says, we could use from the dictionary, or we actually already have all of the words in a single data structure here after we tokenize them. So that should work pretty well. We could also just do for word in fdis.mostcommon. If you don't give a number argument here, most common is all of them, so it's a little bit of a misnomer. Yeah, so we will kick back up with that next time unless I finish it off screen. I don't know. I've got a lot to do, and being sick has kicked my work schedule back a little bit, which is unfortunate. Yeah, okay. So we did do the thing that we said we were going to do, but we don't have, so we have the information within the post. We don't have the information across all the posts yet, and what I want to do is compare cluster. So I want to be able to compare within a specific cluster versus all of Kaggle forums and see what's changed and what's new and what's interesting about this specific cluster. So that's what we'll do next time. And I will commit so that y'all can see the latest version. And this is public, and the link is in the down there. I did a good job. So you can check out the notebook if you would like. All right, I'm gonna wrap it up here. Thank you for joining, everybody. I hope you have a great weekend. We will be back on next Wednesday for a new paper, and I will put up voting for the paper on the YouTube channel, and also see if I can get the Kaggle account, Twitter account, to retweet it. And then we will start reading a new paper. And then next Friday, we'll keep working on this. Although I have had a lot of requests for something in R, like a sort of like introductory R week. So I might take a little break and do an introductory R work, depending on how I'm feeling next week. And then in a couple of weeks, I'm actually going to miss Friday because I'm doing a training. And I'll let you know when that is. And I might pre-record something. I don't know. We'll see. All right. Thank you for joining, everybody. I hope this was helpful and informative, or at least, you learned something. Even if it was the command for commenting out a block of text, which, again, I could never remember. Jake said, "You're going to rap?" No, I'm not. That's all I'm going to say on that. Oh, I committed it twice. All right. I will see you all on Wednesday or next Friday. See you then. Have a good weekend. Or I suppose on Kaggle. I will see you on Kaggle. All right. Goodbye.